Hey everyone, today we're going to be discussing Leetcode problem 90, the interleaving strings problem. So the question is as follows. Given strings S1, S2, and S3, determine whether S3 is formed by an interleaving of S1 and S2. Of course, we have to first understand what do we mean by interleaving. Well, you can think of interleaving as a form of weaving two strings together. So to form an interleaving of two strings, we'll take a character from either string, one character at a time, until both of those strings are depleted. It's important to note that the relative ordering of these characters in the resulting interleaved string is actually going to be preserved. So if we have something like, A, B, C, and then D, E, F, we could interleave them together. Let me put D, E, F. It's important to see A comes before B, comes before C, D comes before E, comes before F, right? So that relative ordering is going to be preserved when you're performing an interleaving, an interlacing of the two characters, of the two strings rather. Let's look at a motivating example here just to build our intuition on how to tackle this problem. Consider the following. Let's say we have three strings here, S1, S2, and S3. So note that S3 is colored to make clear which characters correspond to S1 and which characters correspond to S2. We have the blue characters here corresponding to S1, B, C, C, and then the same for the green characters, which are B, B, C, A. Again, we have that relative ordering property, so you can see in S2, B comes before C, comes before A, and that ordering is preserved. Essentially now, our question is becoming, how could we come up with a valid assignment of characters so that S3 is really assigning each character to either S1 or S2? And we can tackle this problem using a classical technique called recursion. So at the heart of recursion is the idea that we can break a larger problem down into smaller subproblems. In doing so, we sort of take a leap of faith and pretend that we can solve the subproblem, and then that logic helps us think about more clearly how we could solve the larger problem. Often for string problems, this means looking at a single character at a time and then recursing, calling our same function on the remainder of the characters. This actually works really naturally for our problem here. So let's think about how we would solve this problem by hand. At each step, what we're doing is we're trying to identify the origin of the character in S3. So let's start from the first character, B. Well, we note that B can come from either S1 or S2. So in this case, we're going to recurse twice. When we recurse, we note that we can break our problem into a subproblem by essentially exhausting the first character of S3 and the first character of S1. Right? So now our problem is CC and BBCA form an interleaving of BCB, CAC. Or we can do the same thing with S2. We can disregard the first character of S2 because we're matching on it. We're consuming that character. And say, is BCC and then BCA forming an interleaving of BCB, CAC. So in such a manner, we compare the first character of S1 with S3 and the first character of S2 with S3, and then recurse on the remainder of the string if they actually match. Note that only one of these recursive problems has to be true for our problem to return true. Lastly, in recursion, we need to have a stopping point. That is, when do we stop recursing? So we want to keep recursing until there are no characters left in S1 or S2. At that juncture, S3 has to be empty if S3 is to be a valid interleaving. Note that both S1 and S2 have to be empty and not just one or the other. This is because in the case where S1 is the empty string and S2 is the same thing as S3, then S3 could still be a valid interleaving. Lastly, we should also discuss an important invariant of this problem in that S3 length has to be equal to the length of S1 plus the length of S2 in order for it to be a valid interleaving. And that should save us some time to avoid unnecessary computation. So let's take a look at what this recursive solution looks like in practice. So again, we have the same example from above, the same strings, and we're going to look at the recursive calls as a tree, right? So in S3, we can take either B from S1 or B from S2. If B is taken from S1, we're left with the string CC in S1, and then, of course, S2 is going to be the same, and then the other character that's consumed is from S3, so we're left with BCB CAC. Then we compare our first string of S3 with either of the two first characters in S1 or S2. And we see that the B in S3 can only come from S2. So again, we're going to recurse. We're going to consume the character. So now our problem becomes S1 equals CC, S2 equals BCA when we consume that character, S3 equals, after we consume the character, it's CBC, CAC, and so forth. And we continue in this progression. At the other side of the tree, let's say we take B from S2. So now we consume B from S2, so now it's just BCA. And of course, B is also consumed from S3. And then we could continue by taking B again from either S1 or S2, and that will have a different branching structure. Finally, let's take a look at the code. So on leetcode.com, I've written up a solution, and I'm going to walk you guys through it. So this method here is essentially calling our recursive procedure. Before doing anything, of course, we can ask the question, if we sum up the lengths of S1 and S2, if they're not equal to the length of S3, then we know for a fact it cannot be a valid interleaving. Otherwise, we're going to call this memoized recursive solution. But actually, let's look at the plain Jane regular recursive solution first. So we have here that if our base case, if there's no S3, then we must not have any S1 or S2. That has to be true. Otherwise, we return false. So this base case essentially marks the end of the recursion and determines whether or not we have identified an interleaving string. As identified earlier, we can perform an interleaving on either S1 or S2 if the first character matches. So initially we're going to set left and right, S1 or S2 really, to be false. And then we're going to check the first string, S1, check if it's first character. Actually, in this case, we're working backwards, so it's going to be the last character. That just makes it easier to do dynamic programming later, which we'll talk about in a follow-up video. So we'll recurse on all characters except the last of S1 and all characters except the last of S3. Similarly, we'll look at S2. If the last character of S2 is the same as the last character of S3, then we could just recurse on everything but the last character of S2 and everything but the last character of S3. Right, so if we find that either of these leads to an interleaving solution, then we return true. And so that's what this logic here accomplishes. Now, the memoized version is pretty much the exact same thing. The only difference is we're storing the arguments that we're passing to our function, this tuple, in a dictionary. That's literally it. Why do we store it in a dictionary? Because we could look up the answer to previously asked questions, right? And that just reduces the number of queries, recursive calls that we're making our implementation more efficient. This type of solution is called memoization. That helps us reduce the runtime. And because we're solving overlapping subproblems, it's effective here. So there you have it. I'm going to be posting the code, the solution, in GitHub and in a gist. and I will be linking it in the description below. Thank you guys so much for watching, and I hope this was useful to you.